Let now discuss about the unit third is the computer fundamentals. The content is a one-human architecture, instruction set architecture, addressing modes and operands, instruction sequencing, and is in high-level and assembly language programming. The first one is the one-human architecture. This is proposed by John von Neumann in 1945. This is the foundation of most modern computers. The microphone, webcam, scanner, keyboard, mouse are the input devices of the computer. It's an input unit function, the first point of interaction between the user and the computer. As the data conversion is nothing but readable information into binary code, which is a language understood by the computers. These are the contents. It's a memory unit can be classified into two types, primary memory and secondary memory. The primary memory can be classified into RAM, ROM, and secondary memory, magnetic memory and optical memory. Again, the RAM classified into DRAM, SRAM, and ROM, pre-ROM, EEPROM, EEPROM. The magnetic memory, floppy disk, optical memory is nothing but CD, DVD. This is an arithmetic and logical unit. Is a arithmetic and logical unit performs an arithmetic and logical operation. Arithmetic operations such as addition, subtraction, multiplication, division. Logical operations and or not, NAND, NOR, etc. Is a control unit. Is a main memory. From the main memory, the step one is fetch the instruction from the memory and given to the ALU. ALU is nothing but the decode the instruction into the command and transfer the command into the control unit. The control unit is the responsibility is then execute the command, and finally step 4 is to store the instruction into the memory. This is the cycling process of this control unit. As an output units, all of them know the headphones, the printer, plotter, projector, speakers, the monitors, all the output devices of the computer. The registers is nothing but to store the data with especially in this in address form. The registers are small but extremely fast storage units located within the CPU. These registers are essential for efficient execution of instruction, acting as a CPU's immediate workshop. Due to the limited size but high speed, registers plays a critical role in the fast and smooth operation of the CPU, enabling rapid computation and instruction flow. So another one is the operands and computer hardware instruction is the addressing mode, operand, opcode, and the operand. It's a very important thing. These instruction only is understood by the processor. The opcode and the operand. The opcode specify the operation of the performed, while the operands provide the data or the address where data can be found. Types of operation. Data movement operation. The best example of the data movement operation is a move. Move means move the data from one register to the another. So load and store, access memory to retrieve or save the data. So another one is a push and pop. It's manage the data on the stack. These operations ensure that the operands are available in the right location for the processing. It's an arithmetic and logical operation. Arithmetic is all of them know: addition, subtraction, multiplication, division. Logical operation is nothing but and or, X or not. Control flow operation. In this control flow operation, the jump, call, returns instructions are very important. Next one is the types of operands, registers, immediate operands, memory locations, input and output operands. Operand types based on data type: integer operands, boolean operands, floating point operands, character operands. The next is then memory location, address and operation. The instruction set architecture defines the interface between the computer hardware and software. It is a critical element in the computer architecture that specifies the behavior of a machine instruction, how memory accessed, the format of instruction encoding, and how operations are executed by the processor. The overview of instruction set architecture is a specification set of instructions that a processor can execute. It defines the instruction format, numbers and types of operands, opcodes, and how instruction interacts with the memory and the registers. Memory addressing mechanism. These are the addressing of immediate addressing, register addressing, direct addressing, indirect addressing, indexed addressing, relative addressing. These are the addressing modes of the processor. So arithmetic operation performed mathematical computation such as addition, subtraction, multiplication, division. Logical operation performs a bitwise logic such as and or not XOR. Data transfer operation and control flow operation and input output operation read from write to IO devices using in and out or memory mapped IO. System instructions are also there. Instruction sequencing. Types of instruction: data movement instruction, arithmetic logical instruction, control flow instruction, comparison instruction, and IO/instruction. The instruction cycle is a fetch, decode, execute, write back, and update. So fetch the data, decode the instruction, and execute the instruction. Instruction sequence is very important. In executed, most program instructions are executed sequentially unless altered by control flow operations. Okay. These are all the looping and repetition: loop, add, store, and decrement, jump if not zero loop. It's okay. Thank you.